July 3, 2022, Venus, Mars, Jupiter, and Saturn continue to parade in the eastern and southern sky before sunrise. Aquila and Altair are in the east-southeast when evening twilight ends. Chart caption, 2022, July 3, brilliant Venus is in the eastern morning sky with Aquila and Aldebaran. By Jeffrey L. Hunt. Chicago, Illinois, sunrise, 5:21 a.m. CDT, sunset, 8:29 p.m. CDT. Check local sources for sunrise and sunset times for your location. Morning sky. 4 bright planets are visible in the eastern and southern sky before sunrise. Begin to look for them at least an hour before sunrise. Mars and Saturn seem to fade into morning twilight if the search begins too late. Brilliant Venus is low in the east-northeast during morning twilight. Find a clear horizon looking toward the east-northeast. Do not confuse Venus with Capella, about 20 degrees above the northeast horizon and over 25 degrees to the upper left of the morning star. Aldebaran is higher in the sky each morning after its first appearance. Over 7 degrees above the horizon, it is 4.7 degrees to the lower right of Venus. Both easily fit into a binocular field of view, if you've not yet seen the star without optical aid. Aldebaran and the stars of the Hyades star cluster make a sideways letter V. The celestial letter fits into a binocular field of view, but Venus is too far away to fit at the same time. Chart caption, 2022, July 3, Mars, Jupiter, and Saturn are in the southeastern sky before daybreak. Saturn, about 30 degrees above the southern horizon and over 108 degrees from Saturn, is retrograding in eastern Capricornus. It is near the star Deneb Algedi, meaning the kid's tail. Bright Jupiter and dimmer Mars are between Venus and Saturn. The Jovian giant is 40 degrees up in the southeast. The red planet is 21.0 degrees to the lower left of Jupiter and about 1/3 of the way to Venus. Mars is marching eastward toward a conjunction with the Pleiades star cluster on August 20th. On that morning the gap is 5.5 degrees. This morning the cluster is over 32 degrees to the lower left of Mars. Evening sky. Chart caption, 2022, July 3, after sundown, the crescent moon is in the western sky in the belly of Leo. The crescent moon, 21% illuminated, is in the west after sunset. About an hour after sundown, when the dimmer stars begin to appear, the lunar crescent seems to be in the belly of Leo. The constellation is a westward-facing lion, made by a backwards question mark, known as the sickle of Leo, and a triangle outlining its haunches that is tipped by Bola, the tail. Blue-white Regulus is at the bottom of the handle of the sickle. Photo caption, 2021, December 6, the moon with earthshine. Notice that the night portion of the moon is gently illuminated by earthshine, sunlight reflected from Earth's land, oceans, and clouds. Chart caption, 2022, July 3, Vega, Altair and Deneb are in the eastern sky as evening twilight ends. About 2 hours after sundown, near the end of evening twilight, the 3 bright stars of the summer triangle, Vega, Altair, and Deneb, are in the eastern sky. Vega is highest, over 2/3 of the way up in the sky. Deneb is about halfway up in the east-northeast. Altair is over 1/3 of the way up in the sky above the east-southeast horizon. The triangle is quite large, covering a considerable portion of the eastern sky at this hour. The distance from Vega to Altair, the longest side of the triangle, is over 34 degrees. 2022, July 3, Aquila the eagle with Altair is in the east-southeast after sunset. Altair, meaning the flying eagle, is the brightest star in the pattern Aquila, the eagle. Perhaps an eagle can be found in the stars that make a diamond shape and a line. The star is the 8th brightest star that is visible from the mid-northern latitudes. Its distance is nearly 17 light-years. It shines with a brightness of about 10 suns. Of the 50 brightest stars visible in the skies of Earth, only Procyon has less intrinsic brightness than Altair. Frequently, these articles report on the incredible brightness and size of the brightest stars in the night sky. Interesting, Aquila has one of the dimmest stars ever observed. Known as Van Beesbroek star or VB10, this star is slightly farther away than Altair, and beyond the capabilities of the typical skywatcher's telescope. VB10 was first photographed in 1943. It is the second star in a binary star system. The star is a tiny red dwarf star that shines with the intensity of 1/1000th the brightness of our Sun. Its temperature is only about half the Sun's. If it replaced our Sun, its red-orange glow would slightly outshine the full moon phase. In 2009, a NASA program that measured the gravitational effects of planets on their parent stars recorded the presence of an object revolving around VB10. Initially named a cold Jupiter, VB10b, the exoplanet was thought to revolve around the star at a distance nearly equal to Mercury's distance from the Sun, but it was thought to revolve in about 9 months. Mercury revolves around the Sun in less than 1/3 that speed. The slower speed indicates the star's mass is less than our Sun. Subsequent observations of VB10 have ruled out a Jupiter-class planet revolving around the star. The investigations of the actual presence of a planet continue.